So along with graphing functions, we can talk about shifting graphs of functions. So these are shifts. So there are 4 different shifts that we can talk about. We can talk about moving it vertically, horizontally, stretching it in either one of those 2 directions. So 4 types. First type, what does adding a constant to a function do to its graph? So adding a constant, this shifts vertically up by c units if c is positive, and down by c units if c is negative. So if I add a constant to a function, all I do is either move it up or down depending on the sign of c. So for example, let's say this is my function f of x, and I want to know what does the graph of f of x plus 2 look like. The graph of f of x plus 2, that would just mean move everything up by 2, so probably like that. So whenever you add a constant and the constant's positive, just move it up. If you add a constant and the constant's negative, move it down. Next thing I can do, f of x plus c on the inside. Now, adding c to the entire function, that shifted vertically. This time we're going to shift horizontally. So this shifts horizontally to the left if c is positive, and to the right if c is negative. So this kind of works the opposite of how you would think it would. If I add a positive number inside here, I'm going to go to the left, whereas if I add a negative number, I'm going to go to the right. So for example, let's say this is my function f of x. Then the function f of x plus 2 would be shifting it 2 units to the left. So probably something like this. So this would be f of x plus 2. Now you would think that adding a number would shift it to the right because that's the positive direction, but it's the opposite of what you think. So adding 2 on the inside goes 2 to the left, whereas if I put x minus 2, that would have gone 2 to the right. So those are my horizontal and vertical shifts. I can also talk about stretches. So k times f of x, where k is just the constant. So this stretches by a factor of k. So I'm going to have a graph, it's going to stretch it. If k is like 1/2, it'll actually compress it. If k is larger than 1, it'll stretch it. I also want to note, if k is negative, you flip it across the x-axis. So it's going to stretch it, and then if k is negative, flip it across the x-axis. So a couple examples. Let's say this is my f of x. And I want to do maybe 3 times f of x. So 3 is a positive number greater than 1, so it's going to stretch it. So it's going to kind of stretch my graph, kind of like that. So this would be maybe 3 times f of x. It's kind of hard pictorially to do this on paper, but whenever you have a constant out front, it's going to stretch it. If it's less than 1, it'll compress it. Last one, f of k times x. So k times f of x, that was stretching it vertically. Now we're going to be stretching it horizontally. So this scales f of x horizontally by a factor of k if, so this is the star thing, if k is less than 0, flip across the y-axis. I do want to say it scales it horizontally, kind of the opposite, just like we did before. So if k is greater than 1, then f of kx is a compression. So you would think that multiplying all your x's by something larger than 1 would stretch it horizontally, but no, it doesn't. It's the opposite. So for example, kind of do the same picture I've been doing. Let's say that I wanted to do f of 2x. So 2 here is a number that's larger than 1, so you would think that would stretch it, but it doesn't. It compresses it. So I'm going to take this picture and kind of compress it inwards horizontally. So it'll be the same picture, just kind of compressed. So those are all the 4 different translations or shifts that we can do of graphs. So now let's do an example where we kind of put them all together. In these examples, we're going to do 3 of them. We're going to use that f of x, which is x squared, is the following graph. It's just the parabola centered at the origin. So we're going to use this graph to answer a lot of questions. First example. Let's graph f of x is x squared plus 1. Now x squared plus 1 looks an awful lot like just x squared, so that's what I'm going to start with. I'm going to start with a graph that I know, which is x squared. Now how is x squared different from what I have, or what I'm trying to graph? I'm trying to graph x squared plus 1, so I want to add 1 to the entire function. So adding 1 to the entire function, that was our first type, that was a vertical shift. Here we're going up by 1. So this point that was at 0, 0 is going to come up to 0, 1. And this would be my f of x. So you basically start with a graph you know. I knew what x squared looked like, and then trying to move it around to be what I want. So I moved it up by 1. This was f of x, which was x squared plus 1. Let's try a different one. How about let's graph f of x is x minus 2 squared plus 1. Now this doesn't exactly look like x squared, but you can see that it is something squared, so that's what we're going to start with. Start with a graph you know. So this is the graph of x squared. Now use the order of operations to tell you what to do next. So the order of operations says look in parentheses. So here I'm going to replace x by x minus 2. So I'm subtracting a number, that means I'm going to shift to the right. Remember, it's the opposite of what you would think. Just because I'm subtracting doesn't mean left, it means right. So you go from here to here. This point that was at the origin is going to move over. So here's my graph of x minus 2 squared. Now how is that different from what I want? I want x minus 2 squared plus 1. So I'm going to take this graph and move it up by 1. So that's a vertical shift. So this point that was at 2, 0 is now going to be at 2, 1. So this is my graph of f of x. So I started with what I knew. Order of operations told me to replace the x with x minus 2 first and then add 1. And so this was my final graph. Let's do one more of these. Let's graph f of x is negative 2 x plus 1 squared minus 2. There's going to be a lot of steps here. First off, this isn't exactly x squared, but it is something squared, so I'm going to start with what I know. I know what the graph of x squared looks like. That's what it looks like. Now what does the order of operations tell you to do first? It says that in parentheses I have an x plus 1, so let's replace my x by x plus 1. Now adding 1, that's not going to move it to the right like you think it should. It's going to move it to the left. So this point that was at 0, 0 is going to move left to negative 1, 0. So this is the graph of x plus 1 squared. Now what? The order of operations says I should worry about this negative 2. So I'm going to multiply the whole thing by negative 2. Now what does that do? Well, the negative, remember that said to flip it over the x-axis. So now we're looking at type 3. The 2 says I should stretch it. So here's my negative 1. I'm going to flip it across the x-axis and stretch it. So this is negative 2x plus 1 squared. And now what's the last thing I need to do so I can get my graph? I need to subtract 2. So subtract 2 from the whole thing, which means that this point that was at negative 1 is going to be moved down 2 places. So here's my graph of f of x. So I took what I knew and just kind of manipulated it into what I want. So whenever you're shifting graphs, just start with what you know, use the order of operations to go through all the steps and get to the graph that you want.